Good afternoon, children. Sanjay, Sindhu, Madhumita, Netra, Dhanya, Raja, and Tanishka. Good afternoon.
Good afternoon.
Good afternoon.
Good afternoon.
Good afternoon.
Good afternoon.
Yeah, good afternoon. All right. So in this question, a well of inner diameter 14 meters is dug to a depth of, oh, have we done this already, children? Is this file already done? Please let me know.
No, ma'am.
Look at this question, the first question.
We have done a similar question before, ma'am.
Oh, very good, very good. Okay, not this one, right?
No, ma'am, we have not done this one.
Sure, just see the second one.
We didn't do, ma'am.
No, ma'am.
No, ma'am.
Yeah, anyways, because sometimes what happens, we get started and then like we realize we have already done this. Look at this question, children.
No, ma'am, we have not done this.
All right, yeah, thank you. Fine. A well of inner diameter 14 meters. So inner diameter we know that a well is cylindrical. Well is cylindrical. Okay, it's a cylinder, you can say. Don't write anything. Inner diameter is 14. So the inner radius, small r, inner radius is 14 by 2, 7 meters. Is dug to a depth of 15 meters. So height of the well. The depth is nothing but the height. Okay, which is 15 meters. Earth taken out of it has been evenly spread all around it to a width of 7 meters to form an embankment. Okay, so all the earth that is removed from the well is spread all around the well to a width of 7 meters to form an embankment. An embankment is a protective wall that is built around the mouth of the well. Now, clearly here the well is circular. See, the mouth of the well can be circular, can be rectangular. In temples, you would have seen the mouth of the well is rectangular or it's a square. So the well is cuboidal in that case. If the mouth of the well is a rectangle or a square, in that case, the well is cuboidal. If the mouth of the well is circular, then it is a cylindrical well. If the mouth is circular, it's a cylindrical well. If the mouth is a square or a rectangle, then it is a cuboidal well. Am I right, children?
Yes, ma'am.
Yes, ma'am.
Yeah, so these are the only two things possible in the case of a well. So here the mouth of the well is circular. How do we know that? Because the diameter is given. Diameter and radius applies only to a circle. So a well of inner diameter, meaning it is a circular well. The mouth of the well is circular. So it is cylindrical. The well is cylindrical. Okay. Earth taken out of it has been evenly spread all around it to a width of 7 meters. So there's a wall which is built. There is a wall which is built around the mouth of the well. The thickness of the wall is 7 meters. The thickness of the wall is 7 meters. Now the wall has some height. Usually the height of the wall is to the hip, height of your hip, when you lean against, if you've ever drawn water from the well, if you've ever drawn water from a well, you would have noticed that the wall is mostly to the height of your hip. Maybe if you're still, meaning for small children, it may not, be to their hip. But then for a normal adult, it mostly hits the hip of the adult. So it's usually built to that height. Like you can bend and look into the well. It's not very high that you cannot bend and look into the well. It's of that height, which is safe. And you can even bend and look down into the well. So the height, wall which is built around the well will have the height of the well is what is being asked here. It's not very tall. The wall will not be very tall, not very short. So we need to find the height of the embankment, meaning the height of the wall which is built around the mouth of the well. The thickness of the wall is 7 meters. Now the wall is nothing but a cylindrical shell. Cylindrical shell. Cylindrical shell meaning it has inner radius which is equal to the radius of the well, 7 meters. It has an outer radius which is the inner radius plus the thickness, which is 7 plus the thickness 7, which is 14 meters. And it also, the wall also has a height. We need to find this height of the wall. We'll call it H1. We need to find this height of the wall. I'll just try to find a picture in the internet. Just wait, children. Yeah, so you can see it here. You can see the mouth of the well. That's a lid. They have, you can, what you see here is the lid used to cover the well, used to cover the well. So you can see the bucket, the wooden bucket, which is used to draw water from the well. Now look at this is the embankment. This is the embankment. So this embankment is the protective wall, which is built around the mouth of the well. See, the wall is thick. The wall is also cylindrical because it is built around the mouth, which is circular. So it has to be cylindrical, but it is not a solid cylinder. It's a hollow cylinder, which is called a cylindrical shell. So this wall has an inner radius because you can see two circles on the top. You can see two circles on the top. So there is every different circle will have a different radius. So the inner circle, inner radius, small r, outer circle, outer radius, capital R, and the height of the embankment, which is h. Is it understood, children?
Yes, ma'am. Yes, ma'am. Yes.
Yes, ma'am.
Yeah. Yes, children, very nice. So now for the well, For the well, we have only radius and height. Radius is 7 meters, height is 15 meters. For the embankment, we have the inner radius, which is the same as this because it is built around the mouth of the well, right? So the same radius it will have. The inner circle will have the same radius, 7. The outer circle will be the inner radius plus the thickness, which is 7 plus the thickness, width of 7 meters. That's the thickness of the wall. 14 meters of the outer radius. And the height of the embankment is what we have to find. So the equation is volume of the earth removed from the well is equal to volume of the earth in the embankment. Because all the earth that is removed from the well is used to construct the wall. In the situation given to us, all the earth that is removed from the well is completely used to make the wall. So the volume of the earth removed from the well will be the same as the volume of the earth in the wall. So well is a cylinder, its volume is pi r square h. Embankment is a hollow cylinder or a cylindrical shell. So it is pi r square minus r square into h. So pi gets cancelled on both the sides into h1. Pi gets cancelled on both the sides, and then substituting the values, you can find the value of h1. Don't write, children. See the answer. Go through the answer. So pi gets cancelled on both the sides, substitute the values and find the value of h1 or the height of the embankment. So here you can write this as 196 minus 49 also, or you can treat it as a square minus b square, which is a plus b into a minus b. This is in the form a square minus b square. So it's a plus b into a minus b. So a plus b is 21, a minus b is 7, 21 and 7. So you can simplify it like this, or you can directly write the values also. Both are fine. You'll get the same answer. You can also write 196 minus 49 and proceed. All right, let's go to the next one, children. Find the number of coins. See, whenever you have to find a number, remember this. Number is always now area by area or volume by volume. Area by area or volume by volume will give you a number. Now, when it comes to tiling the floor, okay, when it comes to tiling the floor, the number of tiles needed will be area of the floor by the area of each tile. You can understand this. Area of each tile. Number of tiles. Supposing you have to tile up the floor. Okay, so the number of tiles can be calculated like this. Area of the floor, whatever is the area of the floor, length into breadth, divided by the area of each tile. If it is a square tile, side into side, rectangular tile, L into B, whatever. So the area of the floor by the area of each tile will give you the number of tiles you have to purchase, or the volume. Now suppose number of say boxes. Number of boxes that can be stored in a godown. Okay, supposing number of boxes that can be stored in a godown. All right. the number of boxes will be volume of the go down divided by volume of one box. Supposing the volume of the go down is 500 meter cube. Okay, and one box takes up a space of 20 meter cube. Okay, the volume of the go down is 500 meter cubed, and one box occupies a space of 20 meter cubed. So 500 by 20, 0 gets cancelled. 50 by 2, 25. So 25 such boxes can be stored in the go down. So whenever you have to find a number, it is volume by volume or area by area. So here again, number of coins, which means it's volume by volume. Find the number of coins. 1.5. Now a coin is a cylinder. A coin is not a circle. A coin is a cylinder of very small height. The thickness of the coin is the height of the coin. The thickness of the coin is nothing but the height of the coin. Coin is not a circle. It is a cylinder. A coin is a cylinder of very less height. And that height is mostly referred to as thickness. Thickness, which is the height. Thickness of the coin is nothing but the height of the coin. Find the number of coins. So when so coin meaning it's a cylinder. So radius and height. 1.5 centimeter in diameter. So 1.5 by 2 is the radius, or 15 by 20, which is 3 by 4. This is the radius. 3 by 4 centimeters the radius. Why? Because diameter is 1.5. 1.5 by 2 is the radius. Shift the decimal point, 15 by 20, which is 3 by 4. 0.2 centimeters thick. So 0.2. The height is 0.2. So that's nothing but 2 by 10 or 1 by 5. 1 by 5 centimeter. You can take the decimals itself if you are comfortable. Instead of 3 by 4, you can take 0.75. Instead of 1 by 5, you can take 0.2 itself. So that is your choice. Now, coins are melted to form a right circular cylinder. So how many coins you melted, you don't know. Some number of coins are melted to form a right circular cylinder. Now for the cylinder, what's the radius? Radius is 4.5 by 2. 4.5 by 2. That is 45 by 20, which is 9 by 4. Or you can take this 9 by 4. Or if you want the decimal value, you should divide. 2s are 8, 1 is a remainder. 2, 5. So you can take the fraction or the decimal value. To a height of 5 centimeters. So height of the cylinder is 5 centimeters. Am I right or am I wrong? I'm right. Yeah. So like this, we should write down the information given. The two objects in the question are coin and cylinder. Coin itself is a cylinder. So radius, height. Cylinder is a cylinder. Again, radius and height. So for the cylinder, we've used capital R and capital H. For the coin, we've used small r and small h. You can also use R1, H1, R2, H2. That's your choice. For the coin, you can use R1, H1. And for the cylinder, you can use R2, H2. Now to find the number of coins. Number of coins is equal to volume of the cylinder divided by volume of one coin. Volume of the cylinder is pi r square h. And volume of the coin is pi r square h. Pi gets cancelled. Then substitute the values of radius and height of both the solids and find the number of coins. Yeah, go through the answer, children.
From one, can you show previous slide now?
No, I'll share the pictures. 1 minute. Let me send it now. You don't have to take the photos. I'll send it. Yeah, please go through this answer. This one is, instead of doing this, children, you can do what I just worked now. Instead of this one, you can do that is equal to 15 by 20, which is 3 by 4. Like this you can do. Oh yeah, I think I forgot to write N. Oh, fine. I think I told you in a different way here. It's different here. So here I've written, I just noticed children, both are correct. Both are correct. So here I directly wrote volume of the cylinder by volume of the coin. What I've written here is volume of all the coins. Volume of all the coins is equal to the volume of the cylinder. I'm sure you understand that. Here I've written volume of all the coins is equal to the volume of the cylinder. So volume of all the coins will be n into pi r square h. N into pi, because one coin is pi r square h. All the coins n into pi r square h. The equation in words which I've written here is volume of all the coins is equal to the volume of the cylinder. Cylinder is only one cylinder, pi r square h. Coins, there are many coins. So volume of all the coins, one coin is a cylinder, pi r square h into n, number of coins. Now pi gets cancelled on both the sides and substitute the values, and n is 225. You can do it like this, or you can also do this. Number of coins is equal to, you can divide volume of the cylinder by volume of one coin. This also will give you the answer. All right, children. Shall we go to the next one?
Yes, ma'am.
Yeah. A solid iron rectangular block. Solid iron is the material. Rectangular block is not a rectangle, it's a cuboid. Rectangular block, it's a cuboid. You can see the length, breadth, and the height of the cuboid is given in the bracket. Is cast into a hollow cylindrical pipe. That means this rectangular block, it's melted and it is recast into a cylindrical pipe of internal radius and thickness given to you. Find the length of the pipe. So all the iron is the material, all the iron in the cuboid is melted and it is converted to a cylindrical pipe. All the metal, that is iron, in the rectangular block, it's melted and that is recast into a hollow cylindrical pipe. So the volume of the iron will be the same in both the solids. Volume of the iron in the cuboid will be the same as the volume of the iron in the hollow cylindrical pipe. You can see that the radius and thickness of the pipe is given in centimeter, but the dimensions of the cuboid are given in meter. So you need to convert all that to centimeter. 2.2, 1.2, and 1 to centimeter. The answer here. So the equation is volume of the iron in the cuboid is equal to the volume of iron in the cylindrical pipe. That's the equation. After that, it's just substituting the values and go through, children. Ask me if you have any question. Done, children?
Done, ma'am.
All right. So that equation in words is what is very important, children. The cuboid is converted to a pipe. So the volume of the cuboid is equal to the volume of the pipe. All the iron in the cuboid is now in the pipe. There's only one cuboid and one pipe. Not many pipes. It's cast into a hollow cylindrical pipe. Only one pipe. That one cuboid becomes one pipe. So their volumes is the volumes are the same. Write the formula for a cylindrical pipe. It is pi h into r square minus r square, and for the cuboid it is LBH. All right. Yeah. Now use this formula and tell me the answer, children. Number of bottles is equal to. Use that formula. I told you number. How do you find a number? Volume of something by volume of something. Roughly work and don't have to copy the question. Just roughly work and tell me the answer.
Ma'am, I have a doubt.
Yes.
Ma'am, cylindrical bottles are hollow or filled, ma'am?
The bottles are
Hollow or filled, ma'am?
the bottles. They are cylindrical bottles, and the thickness of the wall is not given. Okay. The radius is 3. The height is 6. They're not filled with any liquid. Empty bottle.
Is it hollow cylinder, ma'am?
Yeah, it is a hollow cylinder. Yes. No, but you can. It's not that small r, capital R, because you can. When you read the question, there is nothing mentioned about the thickness of the wall, and it's not internal radius. Simply they've given radius and height. So it is a regular cylinder, not that two radius R, capital R and small r. That not that one.
Yes, ma'am.
Yeah, what's the answer, children? See, I'll tell you something. It does not take this long. I'll tell you why. What's the equation you've taken, children? Or let's say you can do it in two ways. You can either write number of bottles is equal to number of bottles is equal to volume of the hemispherical bowl divided by volume of one cylindrical bottle. Volume of the hemispherical bowl. That's the big thing which has liquid. And this liquid has to be filled in smaller cylindrical bottles. The volume of one cylindrical bottle. So what's the formula to find the volume of a hemispherical ball? 2 by 3 pi r cubed divided by 1 by 3 pi r square h. So radius, they're different. So you can call it R1, R2, or you can use a capital R for the hemisphere and a small r for the cylinder. So that's your choice. I'll just call it R1, R2. So 3 and 3 gets cancelled. Pi and pi gets cancelled. So R2 R1 cube. So you're left with 2 R1 cube divided by R2 square H. Now substitute the values. 2 into R1 cubed. Diameter is 36. So radius is 18. Divided by R2. 3 into 3. Into height is 6. So 6 ones are 6 threes are 3 threes are 9, 9 twos are 18. So it will be 18 into 2 into 8, 2 threes are 6, 6 twos are 12, 18 into 12. 18 into 12 is the answer. 2. Oh, I'm getting 72 here. Did I go wrong anywhere? Oh, R square is 3, right? Where did I go wrong? 2 by 3 into pi. Pi gets cancelled. R cubed. Diameter is 36, so radius is 18. R cubed divided by 1. Oh, it's not 1 by 3. I wrote 1 by 3, I think. Cylinder, pi r square h. I think I wrote 1 by 3. It's yes. Not 1 by. Yeah, sorry. It's cylinder. No, so pi r square h. Pi would have got cancelled. R square. 3 into 3 into h. Like this. H is 6. 6 ones are 6 threes are. 3 and 3 cancels. Then again 3 ones are 3 6 are 18. And then here 2 ones are 2 6 are. So number of bottles is 6 6 are 36 into 2 72. The other way of writing, so you can find number like this. Number is volume by volume. You can do it like this. Or you can also write it as an equation in words. Volume of the liquid. Volume of the liquid in all the cylindrical bottles. Volume of the liquid in all cylindrical bottles is equal to the volume of the liquid in the hemispherical bowl. Volume of the liquid in the hemispherical bowl. Volume of the liquid in all the cylindrical bottles is equal to the volume of the liquid in the hemispherical bowl, because all that liquid which is in the hemispherical bowl, you're emptying it to the cylindrical bottles. So the volumes will be the same. So what is the volume of the liquid in the cylindrical bottles? How many bottles? You don't know. So n into pi into r square radius 3 into 3 into height 6 is equal to Q what this is. sorry, hemisphere. So 2 by 3 into pi into r cubed, meaning 18 into 18 into 18. Like this, you will have to work. All right, children?
Yes, ma'am.
Okay, so that's what you see here. Volume of the liquid in all the bottles. Is equal to the volume of the liquid in the hemispherical bowl. All right, next one. A cylinder lies within a cube, touching all its vertical faces, and a cone lies inside the cylinder. If their heights are the same, with the same base, heights are the same and the base is also also the same. Find the ratio of their volumes. I'm just coming, children, just a minute. Yeah, children. So you can see the figure here. You can see a cylinder lies within a cube. You can see the cube outside. The outermost is the cube. A cylinder lies within a cube. Yes, a cylinder lies within the cube, touching all its vertical faces. What are the vertical faces meaning? The standing faces. A cylinder lies within a cube, touching all its vertical faces. And a cone lies inside the cylinder. You can see that there. If their heights are the same, that is the height of the cone, cylinder, and the cube, they're all the same with the same base. If their heights are the same with the same base, find the ratio of their volumes. Find the ratio of their volumes. All right, so let's do it. Sorry, children. Yeah. So now we'll take the edge of the cube as x. It's marked x here. I think I've worked with A. It's marked x, so I'll just go with x. I'll just go with x. So we know that in a cube, the length, breadth, height are all the same. Now let's first write the solids. So we have a cylinder, we have a cube, or we have a cone. Now we know that in a cube, the length, breadth, height, all are the same. So it's equal to x. Okay. Now the height of the cube is x. The height of the cube is x. So the height of the cylinder is also x because it's given that all of them have the same height. So the height of the cube is x. So the height of the cylinder is x. The height of the cone is also x. Now what about the radius? What about the radius? For a cube, it's not applicable radius, but cylinder and cone, the radius. So you can see that this one, the whole thing is x. This is x. Because the circle touches all the sides of the square. The bottom is a square. This is a square. This one is a square because it's the base of the cube. The bottom is a square because it is the base of a cube. And you can see the circular portion, the circle which is touching all the sides of the square. And the edge of the cube is x. So the diameter of the circle also will be x. The diameter of the circle will be x. So the radius will be x by 2. So the radius of the cone, see the circles of the cone and cylinder will coincide at the bottom. At the bottom, the circular portion of the cylinder, that is the base of the cylinder and the base of the cone, they'll coincide. The diameter is x, so the radius will be x by 2. So radius of the cylinder x by 2, radius of the cone x by 2. So radius is x by 2, height is x because all of them have the same height. The height of the cube is x, so the height of the cylinder and cone is also x. The radius is x by 2. Now let's compare their volumes. Let's compare their volumes now. Okay. So What is given first? Outermost is cube. So let me write the cube first. Volume of cube is to volume of cylinder is to volume of cone. This is what we'll have to find. Okay. So volume of cube is a cube, but meaning side cube. The side is x. So x cube is to cylinder. Cylinder is pi r square h. Pi r square x by 2 the whole square into h, which is x, is to cone 1 by 3 pi r square x by 2 the whole square into h, which is x. So x cubed is to, now we have to take the value of pi as 22 by 7 because supposing the cube also had a pi, then you can cancel the pi everywhere. Supposing the cube also had a pi, or supposing it was a sphere instead of a cube, if it was a sphere, the sphere also has pi in its formula. 4 by 3 pi r cube. In that case, you can cancel the pi in all the three. But here, only two solids have pi in their formula. The cube does not have pi in its formula. So which means you cannot cancel the pi. So you have to take the value of pi. So 22 by 7 into x square into x is x cubed by 2 square is 4 is to 1 by 3. So 1 by 3 into 22 by 7 into x square into x is x cubed by 4. Understood, children?
Yes, ma'am. Yes, ma'am.
Okay. Now you can see x cubed everywhere. So you can cancel x cubed, x cubed, x cubed. In all the three cases, we have x cubed. So they get cancelled. So here we have 1 is to, don't forget 1, 1 is to 22 by 28. Oh, we can simplify, no? So 2 2s are 2 11s. So that will be 11 by 14. 11 by 14. Yeah. So 11 by 14 is to, here again, 2 times and 11. This will be 11 by 42, right, children? 42, 11 by 42. So we found the ratio. That's all. We got the ratio. But the thing is, it's a fraction, 11 by 14 and 11 by 42. So in order to, convert them to numbers like natural numbers, what you'll have to do is take the LCM of 14 and 42. What is the LCM of 14 and 42? 42 itself. 42 itself is the LCM. So multiply every term by 42. Multiply every term. So 1 into 42 is to 11 by 14 into 42. You can do the same thing everywhere. Whatever you do, you should do the same everywhere. Is to 11 by 42 into 42. So 1 into 42 is 42 is to here 14 ones are 14 threes are. So 11 threes are 33 is to 42 and 42 gets cancelled is to 11. So the required ratio is 42 is to 33 is to 11. See, the cube is the outermost. So you can see its volume is the greatest, 42. Then inside that is a cylinder, which is 33. And inside that is a cone, which should be 11 because you can make out from the formula itself that if, a cylinder, if a cylinder and a cone, if a cylinder and a cone have the same radius and same height, if a cylinder and a cone have the same radius and the same height, then the volume of the cylinder is pi r square h. The volume of the cone is 1/3 of the volume of the cylinder, pi r square h. You can see the formula. Pi r square h, 1/3 of pi r square h, which means if a cylinder and a cone have the same radius and same height. If a cylinder and a cone have the same radius and same height, then volume of cone is 1/3 of the volume of the cylinder. That's why if the cylinder is pi r square h, cone is 1/3 of this, 1/3 pi r square h. So keeping this in mind, you can see if the volume of the cylinder is 33 parts, then the volume of the cone will be 1/3 of that. That is divided by 3, 11 parts. 33 by 3, 11. Am I clear, children?
Yes, ma'am.
All right, children. So that's what you see here, but using A. In that figure, we had X, so I explained using X. So I've taken the edges A. So you can see radius and height. A by 2, height is A. Height is A everywhere. Radius is A by 2. So I found the volume separately. Volume V1, V2. I told you use the value of pi because instead of a cube, if it was a sphere or a hemisphere, instead of a cube, if it was a sphere or a hemisphere, then that formula has a pi. Then you can cancel the pi everywhere. But here cube does not have a pi in it. So that's why we take the value of pi 22 by 7. Otherwise, don't take. You can cancel the pi's. So we took the value 22 by 7. We found the volume of the cylinder and the volume of the cone, and then the ratio. V1 is to V2 is to V3. A cubed gets cancelled. Then you have this multiplied by the LCM, 42, 42, 42. And this is the required ratio. I'll send the picture. Oh, that's all in this presentation. Okay. A hollow sphere. See that? External, internal. Hollow sphere. So then what will be the volume here, children? What's the formula to find the volume? Hollow sphere. What is the formula to find the volume of a sphere? What is the formula to find the volume of a sphere?
4 by 3 pi r cube. 4 by 3 pi r cube.
Very good. 4 by 3 pi r cube. 4 by 3. 4 by 3 pi r cubed. Now, if it's a hollow sphere, then, like I told you, the example of a hollow sphere, a perfect, a coconut which is in the shape of a perfect sphere. If a coconut is perfectly spherical, then it's a good example of a hollow sphere. The volume of a hollow sphere is 4 by 3 external volume minus internal volume. Hollow sphere, it is external volume. External volume minus internal volume. Internal volume. So external volume will be 4 by 3 pi capital R cubed. Minus internal volume will be 4 by 3 pi small r cubed. So on taking 4 by 3 pi common, you will get r cubed minus r cubed. So this is the formula to find the volume of a hollow sphere. And how do you know it is a sphere like this? Because they have mentioned external diameter, internal diameter. That means external radius, internal radius. Now this is melted. Okay, so there is a hollow sphere. It's melted to form a cone. So when one solid is melted and recast into another solid, their volumes will be the same. Always. If one solid is melted and recast into another solid, then their volumes will be the same. So clearly, volume of the material in the hollow sphere is equal to the volume of the material in the cone. Supposing the sphere is made of iron, the volume of the iron in the sphere will be the same as the volume of the iron, volume of the material Okay, it's the volume of the iron in the cone. So that's the equation. Once you write that, working is very, very easy. You just have to write that equation in words. Volume of the material, or simply volume of the cone. Volume of the cone meaning volume of the material in the cone is equal to volume of the hollow sphere. Volume of the hollow sphere. Okay, so cone is 1 by 3 pi r square h, and sphere is 4 by 3 pi capital R cubed minus small r cubed. So maybe you can call this R1 because there's a clash. No, there's R here and there's R here also. So you can just call this R1. So now 3 on either side gets cancelled, pi gets cancelled. The radius of the cone, R1 is the radius of the cone, which is 4. 4 into 4. Into height of the cone, we have to find is equal to 4, open bracket, capital R. External diameter is 8. So radius is 4 cubed minus internal diameter is 4. Radius is 2 cubed. So see here, you have an equation in which h is the unknown. So solve and find the value of h. So how did these two steps happen? Because you wrote this step. This is the most important step. You should know. You should read the question and write this one in words. You should not find the volume of the cone separately and hollow sphere separately. You're only wasting time. You will get the answer. But instead of getting the answer in 5 minutes, you will take 15 minutes. You lose 10 minutes. So you will not be able to answer one question in the exam. And that's how we say the paper is lengthy. Sometimes the paper is really lengthy. That also I've seen. Sometimes crazily the teachers set such a lengthy paper. Schools are expected to motivate students, but they do the opposite sometimes. They make it so lengthy that even the teacher, if she takes up the exam, she cannot finish it. It's like that. We should ask the teacher to solve the same paper in 3 hours. She'll not be able to do it. Then how can students do it? So sometimes it's crazily long, the paper. So otherwise, I'm saying like a reasonably set paper, a reasonably set paper. If you suppose work, so that is the questions will be like you will be able to finish it in just 3 hours. But if you lose time like this, say some two sums instead of working it for 5 minutes, you worked it for 15 minutes. So one sum you lose 10 minutes, other sum you lose 10 minutes. So 20 minutes solid you wasted. So sure that you will not be able to complete the paper. So you will say the paper is lengthy. This is how we say that a reasonable paper is also lengthy because we waste time in calculation like this. You should not find this and this separately. You must write this equation. Volume of the cone is equal to the volume of the hollow sphere. So that way you can simplify easily. Pi gets cancelled, 3 gets cancelled. See, it's so easy. This is a 4-mark or a 3-mark question. But you can do it if you're very confident, in 2 minutes. 2 minutes you can finish it. Or as I said, 5 minutes after giving all the details, the value of small r, capital R, h, all the details, you can finish it in 5 minutes. Understood, children?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
College. Same thing. Everything is the same. See, a solid sphere of radius. For a sphere, radius is enough. There's a solid sphere and only one radius is given. So it's 4 by 3 pi r cube. That's all. It's melted and then cast into not take out from there. It's cast into small spherical balls, each of diameter. So this one is also a sphere. Both are spheres. That means one big sphere. One big sphere. Okay, is melted and cast into smaller spheres of the same size. So find the number of spheres formed. How many spheres are formed? That's the question. So what is the equation? Tell me. What's the equation in words, children? What is the equation in words? Yeah, you must say.
Ma'am,
Yes, Raja, very good. Yes.
Let n be the number of balls made by the solid sphere.
Correct. Let the number of balls obtained be n. Correct.
And n into let the volume of n into volume of each small ball, that is
Very
0.6
good. N
centimeter.
into volume of each small sphere. Very good. Each small sphere. Yeah, is equal to?
Volume of the solid sphere.
Very good. Volume of the solid sphere. Very, very good. Exactly. Now continue, Raja. So n into. So 1 minute, Raja. So volume of all the small spheres is equal to the volume of the big sphere. So how will you write the volume of all the small spheres? Volume of one small sphere into n.
Yes, ma'am.
How will we write? Yeah, volume of all the small spheres. Each sphere volume into n. Let the number of small spheres formed be n. So n into this will be equal to the volume of the solid sphere. Yes, Raja, continue. N into?
N into 4 by 3 pi r cube is the LHS, and RHS is 4 by 3 pi r cube. Let the RHS be radius of RHS be a capital R.
Very good, very good. Yeah. So now what happens? 4 by 3 pi, 4 by 3 pi gets cancelled. See, so easily we finished. Now n into what is the radius of the small one? 3. So 3 into 3 into 3 is equal to, oh no, no, no,
I'm
no.
point.
0.3, yeah. 0.3 is equal to, big one is 3. So 3 into 3 into 3. That's all. So I've taken 0.3 as 3 by 10. So the number of spherical balls obtained is equal to 1000. Yeah. How many spherical bullets? Spherical bullets. Sometimes when we hear the the word bullet, we feel it's cylindrical. It's given spherical, sphere. How many spherical bullets can be made out of a solid cube? So there's a sphere, there's a cube. How many spherical bullets can be made out of a solid cube of lead? Lead is the material. Cube of lead. Lead is the material. Like iron, lead. Lead is the material whose edge is 44 centimeters, each bullet being 4 centimeters in diameter. I'm sure Raja knows this well. Somebody else try this. Yeah.
Ma'am, n is equal to the number of spherical bullets which can be made, and
Ah,
n
ah,
we should divide the volume of solid cube by the measure of one by the volume of one bullet, ma'am.
very good. Volume of one bullet. This is also correct. Number of small bullets formed is equal to volume of the cube by volume of one bullet. It's the same. Both are the same because cross multiply this. What will you get? N into volume of one bullet. N when you cross multiply n into volume of one bullet is equal to volume of cube. Both are the same. Is equal to volume of cube. N into volume of one bullet is equal to, because n into volume of one bullet is the volume of all the bullets, is equal to the volume of the cube. So you can write it like this or like this. Both are correct. All the spherical bullets. So n into 4 by 3 pi r cube. Cube, a cube. Then substitute the values and the number of bullets obtained is 251. Yeah, this is a test. All of you work and tell me the answer. All of you please work this and give me the answer. I'm right here, children. Let me know the answer once you finish working.
Ma'am?
Yeah.
Ma'am, is the answer 20,790?
20,790. No. No. Yeah, I'm right here, children. I'm just putting my mic on mute. I'm right here. Please let me know the answer.
Ma'am,
Yeah, Madhumita?
I got 3,307.5, ma'am.
No.
Ma'am?
Did you take the radius as 2.1 or you took 4.2?
Ma'am?
I took it as 4.2, ma'am.
2.2 is it? Oh, that's where you went wrong.
No, ma'am, 4.2.
One second. Madhumita, you got your mistake?
Yes, ma'am. Yes, ma'am.
Okay, yeah. Who's that? The next, Raja, please wait. Somebody else wanted to say something.
Ma'am, I got 1,500, ma'am.
Yeah, Tanishka, share your working on WhatsApp.
Yes, ma'am.
Yes, Raja?
Yes, ma'am, I too got 1500. I got wrong with the cubing of radius.
Ma'am, I got
Okay.
1,000.
Netra?
Ma'am, I got 15,000.
10 extra you've got.
Yes, ma'am.
Okay, share your working. Let me see. All of you put your answers on WhatsApp. Yeah, what about the others? Are you all in the meeting? Who's there? Tanishka, Sindhu, Sanjay. Raise your hands, class. Use the emoji, raise your hand. Madhumita, Netra, Sanjay, Sindhu, Raja. Tanishka is there. Okay. Danya was there. She left. Who else was there? Okay. Yes, Sindhu, Sanjay?
Ma'am, doing that.
All right. Okay. Okay, I've not received anything on WhatsApp. It's time. We have to wind up the session. So see here, children. Just make out the what mistake you've made. So 66, 22, 21 all in centimeter. Radius 4.2 by 2, 2.1 or 21 by 10. So this is the equation. Volume of all the spherical shots is equal to the volume of the rectangular solid. So for the rectangular solid, which is a cuboid, formula is L into B into H. And for the sphere, all the spheres, N into 4 by 3 pi r cubed. So you can see here, N 4 by 3 pi r cubed. So 21 by 10, 3 times, is equal to LBH, 66, 42, and 21. So on transposing these fractions, all these will go to the numerator on the other side. All these will go to the numerator on the other side. So I've written 3 into 7 is 21. See, 66, 42, 21, 66, 42, 21. And this I've just multiplied and written the number. 3 7 are 21, 21,000. And these numbers will come to the denominator. All these numbers will come to the denominator. So you can see 4, 21, 24, 22, 21, 21, 21. On simplifying this, we get 21, 22 3 times, 21, 21, 21 2 times, 21,000 times, 4, 250 times, and 250 into 6 is 1,500. 250 into 6 is 1,500. Where do you think people who went wrong, where do you think you went wrong?
Ma'am, I sent my working now.
Ma'am, I went wrong while I wrote as n into 4 by 3 pi r cube. Then I wrote the equation correctly, but while multiplying, instead of writing 21 by 10 3 times, I just wrote 21 by 10 once. That's why I did
Ma'am,
not.
I went wrong in cancelling.
Oh, Netra, okay.
I missed to cube the radius.
Correct, correct. You just wrote the radius once, you're saying.
Yes, ma'am.
Okay, okay. We'll have to be careful.
Ma'am, I made two mistakes. First, I didn't write it as 21 by 10 and I wrote it as 42 by 10, ma'am. I didn't convert diameter into radius. And then also that I wrote it only once, ma'am.
That's what I told you first. Somehow I had a feeling that you wouldn't have taken 2.1. You would have taken 4.2. So that you're written 42 by 10, is it?
Yes, ma'am.
Okay, okay. So that's what. These answers are very easy, but we could go wrong like this by mistake, taking the diameter as radius. But these I should say silly mistakes, are very common among children, but we have to be smart. It is common, but you have to handle that situation smartly.
Yes, ma'am.
All right. Okay, good. Tanishka, I can see you're working, but you've written n is equal to, I don't know, n into, no?
Yes, ma'am.
Yeah, yeah. $66, $42, $21. Oh, and okay, then in the denominator you have 422. Your denominator is incorrect, but how are you getting it? 1 minute. Oh, you cancelled there, is it? Okay, okay, fine, fine. Good, Tanishka. Just that you have to write n into.
Yes.
Yeah. Okay, I'll share the answer to this one also. What was the last one we did? Oh, after this, I will send my. Just see if you have got all the pictures, children. Once you check your WhatsApp and tell me.
Yes, ma'am. You got it.
Yeah. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you.
Thank you, ma'am.
Thank you, children.
Thank you,
Thank you,
ma'am.
children. Thank you, children.